Hello and welcome. Over the last year or so, I've started using scriptable objects increasingly in my workflow, and they've added a lot of value in situations that suit their strong points. I came across some useful functionality that allowed me to cut down on manual intervention, reduce my game's build size, and decrease its load time, so I'll highlight these as we go along. Scriptable objects are a great bridge between original assets and adjusted game-ready versions of these assets. Yes, it takes a bit more time to set up an automated workflow rather than performing the required change manually a few times, but once implemented, the change can be applied to many more instances automatically, and you can easily adjust the scripts to apply future tweaks and parameter changes on all instances for very little manual effort. This isn't another What are Scriptable Objects video. There are various good quality ones available on YouTube. Instead, I'm going to show a few concrete examples of how I use them and the value they bring to the development process. Let's start with a simple one. My game uses many brushes or height map stamps. For example, here are various stamps for stamping potentially huge landmasses at once. Note that these are currently limited to 2K resolution, while some of them are 4K. If we want to stretch these stamps over a very large area, we need them to be high resolution to prevent the terrain from becoming an inefficient version of Minecraft, like for this 256 resolution stamp. So we want to keep these at 2K. However, other brushes will be used on much smaller areas. For example, when painting smaller details onto the large landmasses. Using 2K resolution for these would be wasting memory and processing power on needlessly detailed brushes. So we can make our game build smaller and faster by reducing the size of some of the stamps or brushes. In addition, I wanted to standardize the range of the height maps, so that the minimum value is 0 and the maximum value is 1 for all brushes. Finally, I also wanted to create a much smaller icon for each brush, which can be used in the UI. This means our scriptable object will take some inputs, both assets and parameters, and produce output assets that are more suitable than the original assets, as well as completely new assets derived from the inputs. Note that you can add buttons to scriptable objects. When you click it, it does its thing and provides you with an icon saved as a PNG file with transparency, and an adjusted height map texture saved as an actual Unity asset. These are also automatically linked to the scriptable object. We need a simple editor script that creates the button on the editor panel, and calls a certain method when clicked. This method creates the icon and the adjusted height map texture. We're not going into these details, but here's the code if you're interested. The two important bits I do want to point out is the creation of the asset and the fact that you have to set the scriptable object to dirty and then call save assets to make sure that references to the newly created assets are saved with the scriptable object. If you don't do this, the next time you open the project, those references will be broken and show up as missing again. So for each height map or brush that we want in the game, we create one of these scriptable objects. Click the button to create the game-ready assets and reference them in the editor on other scripts that would use them. But we can go one step further. We create another scriptable object that takes as input a list of folders containing all of our instances of these height maps. This one has a button that automatically finds all instances in the list of folders and creates the icons and adjusted textures for all of them in one go, making it easy to apply future tweaks. But there's one important thing we haven't touched on yet. As it stands, the scriptable object references both the original texture as well as the derived icon and game-ready texture. When the game is built, all three of these will be included in the build, making things worse on the game size front. However, since we only need the original texture in the editor, we can encapsulate everything except the game-ready assets in a Unity editor directive. Now, when the game is compiled, everything inside this directive will be ignored, including the original textures, reducing the build size. As our last example, let's consider quite a complex workflow step. I bought these two asset packs as part of bargain bundles over the years. They are modular, consisting of hundreds of parts each, and can be combined into various configurations to create a variety of different buildings with the same building blocks. I adapted their shaders slightly to fit into my world, and I was able to reduce all of the parts I use so far into only 2 different shaders. One of the shaders has 2 materials using it, and the other 27. There are 127 different parts using these materials, some with up to 5 levels of details, leading to a total of about 300 meshes. I wanted to combine all of this into only 2 combined meshes and 2 combined materials, one for each shader. This would allow me to render all lots of all parts of all instances of these buildings in only 2 indirect draw calls, with all the preparations happening on parallel threads. So I create a scriptable object for building part and populate it with all the materials and available LOD meshes of that part. Next, you will notice these assets are extremely high quality. I don't necessarily need that much quality, since the camera generally won't get as close to the buildings in my game. On the other hand, for some of the models, the worst LODs don't work all that well, having large gaps in them that are noticeable even from far off. So I've added parameters allowing me to skip the first X best and last Y worst LODs. I've also built in an automated process that is able to further reduce the last use LOD by decimating the mesh in steps and adding those as worst LODs. Now the combining scriptable object takes all of these 127 paths and does the following for each of the shaders they use between them. I've created an arrayed version of each of the shaders, and it now creates a material using the corresponding arrayed shader. It then extracts the textures and parameters of each material using that shader and populates the arrayed shader with these. Then it combines all the LODs of all the meshes using those materials into one huge mesh, keeping track of LOD count per model, where each LOD starts and stops, bounds per model, etc. After all of this, we are left with 2 meshes and 2 materials, as opposed to the almost 300 meshes and 29 materials we started off with. And we can render all LODs of all instances using only 2 indirect draw calls. And if we later decide we need a bit more detail in some building parts, we simply reduce the number of ignored first LODs for those parts and run the scriptable object again to recreate the combined meshes. We can also simply add on more parts and combine them too. And again, we take care to only include the final combined data in the build, since for the build, all the individual building blocks can be discarded once they have been combined. This speeds up rendering and reduces build size. Also, fewer larger assets load faster than more smaller ones. And that's it for this video. Please like if you enjoyed the video, leave a comment, subscribe to this channel, wishlist and follow MinerDRT on Steam, or join the Discord server to stay up to date. All the links are down below. Also, feel free to ask specific questions you may have. Thanks for your time and support.